Hello guys. So today we are going to discuss the cross-cutting concern pattern that is used in microservice architecture. So what is cross-cutting pattern? So cross-cutting concern is a concern that is applicable throughout the application and it affects the entire application. It is not specific to any functionality. This is applicable or these concerns are applicable throughout the application. So like security. So you need security throughout application irrespective of any functionality. In each service you require security. Performance. You require high performance in every module. You need request tracing every application. Exception handling is required irrespective of any functionality. Logging is required throughout application. Monitoring is also required and communication with external application is required. So these are the common concern that is applicable throughout the application. In microservice architecture, apart from above listed concern, you need to take care of few more additional concern like centralized configuration that we are going to discuss in further slide, server registry and discovery that also we are going to discuss in this video, and then service to service communication, how you will communicate with service in within microservices, and then deployment, so how you are going to deploy in microservice architecture. So today we are going to discuss centralized configuration and service registry. So why we need externalized configuration? So what is the need of this? So what happen in each application you use configuration related to infrastructure, like you need to connect with DB, you need to or application need to connect with MQ, and also application also need to connect with third party like payment processing or any other application from which it to pick the data or it give the data. So there are multiple URLs that need to be configured. So URL for DB connection, URL for MQ, URL for payment processing or any third party connection. So there are a lot of multiple configuration that you are going to configure. Now suppose this service is going to deploy in multiple environment like dev environment, testing environment, UAT environment, prod environment, load testing environment, and any other post-production environment. So so if this service is going to deploy in multiple environment, and if every environment is having their own infrastructure URL. So for testing environment, you have a separate DB connection. For UAT environment, you have separate DB connection. For prod environment, you have separate DB connection. So if you are going to change in each environment, it is very tough process because you have multiple services and it is not possible to change in each service. So, how to deploy service in any environment without modifying code? So that is the question. That is the problem statement. That's why we come up with externalized configuration. Apart from this problem, the second problem is that if like you are configure some property currency is equal to USD, and that configuration you need to change. So in monolith application, you can easily change in one place. But in microservice architecture, because you have many services, so you might be needed to change that currency in multiple places. So how to avoid that? So that's why we need a centralized, externalized configuration. So your configuration should be centralized and it should be external to your deployment. So this is typical architecture with cloud config server that we use. So we have multiple services like order service, payment service, card service, delivery service. So what happen? Every service is going to connect with cloud config server. So in cloud config server is a new service that you can easily create it using Spring IO URL. So you need to give only one dependency that cloud config server, and you don't need to put anything. And this cloud config server is connected to config repository. It might be GitHub, it might be SVN, or cloud config server may be attached to any file. Configuration will be either in config repository or on a hard disk. So what happen when when your service is going to start, when your order service is going to start, it will read the property file from cloud config server, and cloud config server will take those property file from config repository or file system. Now for each environment you have separate property file or YAML file. So depending on the environment that you put in here, it will pull that property file up with respect to that environment only. So for test environment, you have a separate property file. You mention when you connect to cloud config server that I need property file from the test. I need test property file. So there will be separate property file for separate environment, and also for each service you will have separate property file. So that's how you can easily manage your property file. Now, if any property is going to change, you don't need to do anything. Only just in GitHub repository, it automatically going to refresh and upload the updated property into the service. So it's very easy. Now you can easily deploy your order service or payment service in any environment. You don't need to modify when you deploy in that environment. It automatically pick the property file from GitHub depending on the configuration that you have done in. Now, second is service discovery pattern. So now we have many microservices that are deployed in your in, in your application servers or in your machines. Now, how does consumer or router know that what all available service instances are there and what is their location? It is not possible to tell every client that yeah, my service is deployed in this location and this is my URL. So how they will come to know? And now it may be possible that your service is deployed in multiple instances because you want to make them high available and they are behind load balancer. So this structure you don't want to expose to your client. So what you do that give the name of the service, only name of the service. You don't need to provide the instance of the service and their location, IP, all those things. You just give the name of the service, and then we use a register and discovery service like Netflix Eureka. So you can see that this is our API gateway. This is client. Client is connected to API gateway, and then we have multiple services: order service, payment service, card service, and delivery service. Each service is attached with Netflix Eureka server. Okay. So what happen when this service is started? It will register itself to the Eureka server. So that in Eureka server you can see that this service is there and is running or down. So that also can be checked. Eureka server is going to ping every time this service. So if order service is deployed in two instances, every instance will be registered in Eureka server. So Eureka server has registry of all the instance. It will ping to the services in 5 minutes or 10 minutes, whatever you have configured 5 seconds, that the service is alive or not. Now, what happen if client is want to connect with order service? It only say to your API gateway that I want order service. Now, what happen? API gateway will query from Eureka server that where this order service is deployed. What Eureka server will do, it will give one one instance. It might be possible that there are multiple instances are there of order service in this Eureka server. So it will give one instance. So internally it is use the Riven load balancer to find the available service, and it provide that location of the service to the API gateway, and then this API gateway will connect to this service. Now, same thing will happen if order service is going to connect with payment service. So if order service need to connect with payment service, what will happen? It will look up or do the query from Eureka server that give me the instance of payment service which is free. Eureka server provide the instance of the payment service to order service, and then order service will connect to the payment service using run load balancer. Now, how you can do the high availability, how you can deploy Eureka server in high availability mode? Because this is center server and every service is registered with this one. So Eureka should be working every time. So this should not be down. So we need to keep at least two or more Eureka server in production. So how they use the peer-to-peer replication. So what is the meaning of peer-to-peer replication? That if order service is registered to Eureka server, it will replicate that instance to second Eureka server. So order service don't need to connect with both the server. Order service will connect to only Eureka server, and internally this instance of Eureka server will connect to second instance of Eureka server, and whatever information it has, it provide to this. It might be possible that payment service will connected to second Eureka server, then what will happen? It will replicate the same information to first Eureka server. So that's how Eureka server will work. So now you can see that how our application work with Eureka server and Cloud Config server. So requests come to API like I want data from order service. API gateway will check from the Eureka server that give me instance of order service which is present, or Eureka server will provide the instance of order service to the API gateway. Then API gateway will connect to order service, and order service will load all the properties from the cloud config server. So that's these 2 points that I have covered in this tutorial. In next part, I am going to cover blue green deployment and circuit breaker that are also very important. Thanks for listening and thank you very much.